This now about second video about section 2.11 motion with constant acceleration. Remember acceleration يعني increasing the speed with zero initial velocity يعني initially was not moving. So it's telling me activity 1. Let's plot this graph. I'm going to plot it. At time equal to 0, velocity was 0. This represents time axis, this represents velocity axis. So at time equal to 0, velocity was 0. At time equal to 1, pay attention 1, velocity was 0.5. So I have this point over here. At time equal to 2, it's gonna be 1. At time equal to 3, 3.5. At time equal to 4, 2. At time equal to 5, and so on. As you can see, I have a graph over here until, for example, 7. My here is wrong, and let me here just take a look over here. At 7, it was a 3.5. So you're gonna have this graph over here. Take a look. The value of velocity from time 0 to 7, they are increasing. After it, at time equal to 8, 9, all of them have same value, 3.5. So it's gonna be horizontal line. It means that here I'm moving, but with a constant velocity. Constant velocity. I'm not increasing my velocity. So over here, acceleration gonna be 0. Acceleration over here gonna be slope. Why? Because always in a VT graph, slope represented by acceleration. Okay. Now you have the picture overview. Let's get back to over here. Of course, you're gonna open the ebook with you because I can, for example, draw the graph over here with all the time. So let me try to draw it over here. When time was 0, it was 0. When time, for example, it was 1, 0.5. When time was 2, it was 1. Let's say, for example, directly I'm gonna cut it. When time was 7, it was a 3.5. When time was, for example, 10, it was also a 3.5. So the graph gonna be this. Gonna be a straight line connecting over here, and over here gonna have a straight horizontal line. So let's get back to our first question. First question telling me plot the graph. I plot it. That's it. Okay. Second point is telling me find the slope between 0 second and 4 second. Let's get back to our graph. When it was 0 second, velocity was 0. So let's try to create the points. Let's create point A over here. Point A has 0, 0. And let's see point B have a 4 second coordinate. If we have 4 and get back to our table, when this was 4, velocity was 2. Okay, let's get the slope. So I'm calling this 1, I'm calling this is 2. So slope over here gonna represent acceleration. Always the slope in the VT graph represent what? Acceleration. So what do we have over here? y2 minus y1 over, which is minus 0, over x2 over 0. So acceleration is going to be 0.5 meter per second squared. Now what I mean by this? Acceleration equal to 0.5 meter per second squared. It means that I'm increasing my speed 0.5 meter per second every second. That's about part C, about explaining it. Okay. Then it's telling me find the slope between 4 and 6. Between 4 and 6. It's gonna be the same answer as you can do. So between part D, gonna be the same 0.5 meter per second. You can do it by yourself, test yourself over here. Now part E is telling me find the slope of a graph between 7 second and 10 second. Okay, let's find it. So at 7 second, velocity was 3.5. At 10 second, it was also 3.5. Let's get the slope. هلا بيركم to the graph is horizontal. Horizontal means it's constant. Constant velocity and acceleration is 0. But let's prove it. Let's prove acceleration is 0 over here. There is no increasing, just moving in a constant velocity. So let's go over here. Acceleration, same as the slope, equal to y2 minus y1 over x2 minus x1. So 3.5 minus 3.5 equal, for example, 10 minus 7, 0 over 3 give me 0. That's how I prove that there is no acceleration. There is no what? Acceleration. Or the particle, it moves with a constant velocity. Particle, it moves with constant velocity. And the same idea, if I'm moving from position A, position B, position C, position D, my velocity is constant. 3.5, 3.5, 3.5, 3.5. If I have exam, I'm accelerating by 0.5, what gonna be? A, B, C, D. If I started by 0.5 meter per second, this is gonna be 1, here gonna be 1.5, here gonna be 2, and so on. I'm speeding. Okay, let's go to part F. Part F is telling me during which time interval velocity constant between, of course, you're gonna look at the graph, between which was constant between 7 and 10. Between 7 and 10. It told me get the displacement. Always remember displacement. If we have VT graph, it represent area under the graph. Area under the graph. Let's get back to our here. At time equal to 7, this was. At time equal to 10, this was. As you can see, this part of the graph represent what? Let's get it if I have to know. From 7 to 10, how much I move, for example? 3 units. From 0 till the maximum, it means what? 3.5. This is going to be a rectangle. Okay, what the area of the rectangle? Area of rectangle equal to length by what? By width. The length was 3 multiplied by 3.5 equal to 10.5 meter. Okay, at part G, it's telling me during which interval of time acceleration is constant. Acceleration what? Is constant. So acceleration is constant between 0 second and what? 7 second. Let me here just draw the graph again. It's better for you. Here was 0. So at 7 second, velocity was, for example, 3.5. Good? And the graph was like this shaped. So take a look. I want the displacement under the graph. I take only the region where the part of the graph with the x-axis. As you can see, this looks like what? Triangle. What the area of a triangle? Height by base divided by what? By 2. If you look over here, this part of the graph can represent height. And this part of the graph can represent base. And divide by 2. So the area over here, what gonna be? From 0 to 7, how much I moved? 7 units. Multiplied by the base, multiplied by the height. It was 0 velocity, then it reaches maximum at 3.5. So the height over here, all of it gonna be from here to here gonna be 3.5. 3.5 divided by 2. Total distance is gonna be 12.25 meter. Okay, over here. Part H, what is telling me? Describe the motion during the first 10 seconds. Describe the motion first. Okay, just simply from 0 to 7, I'm accelerating at a rate 0.5 meter per second squared. I'm accelerating, but from time 7 till time 10, I maintained my speed at 3.5 meter per second. I maintain it, so acceleration over here gonna be 0. That's about this exercise, but let's complete over here. That's about the graph. Okay, now we're going to also introduce something called equation of motion. New equation for motion for UARM. New equation of motion. Let's get, for example, over here. So now let's get, for example, before we shall say UARM. I have to know what equation of motion we have. Equation of motion. First equation of motion gonna be taken. It's gonna be x equal to half at squared. This first one. Second one gonna be v final equal to at plus v initial. I'm gonna explain what I mean by that now. And third one gonna be x equal to v initial plus v final divided by 2, both of them multiplied by t. Okay, I'm gonna explain each one represent. Let's start with the first one. X equal to half at squared. X represent position, A represent acceleration, T represent what? Time. Okay, let's complete. Time always should be in second, acceleration meter per second squared, here represent in meter. Second equation, what do we have? V final equal to at plus V initial. V final means final speed I got. Final speed. Acceleration, acceleration and time. V initial means starting speed. Starting speed. Third one, for example, I'm gonna use it. Which one is X equal to V initial plus V final multiplied by T over 2. Okay. When, for example, I use this rule, when I use this, when I use that, I use this rule, for example, let me choose my font, my color. I use this rule when starting from rest. I use this rule when no distance given. I use this rule when no acceleration given. You're gonna see it now, what I mean by it. So let's get back to our example over here. Please focus on it and open your copybook. Open your ebook, because I can, for example, I'll open it in another thing on my laptop. So we have a motorcycle rest at a rate 3 meters per second squared for 6 seconds. I have from the text, I have to get the given. Okay, accelerated from rest. Rest يعني V initial was 0, was not moving. What does this value means? It doesn't tell you acceleration or velocity, but pay attention. What the unit meter per second squared? Okay, it means that the acceleration was 3 meters per what? Second squared. And time just represent time. So let's get back to my equation over here. So over here, example 2.8, page 116 on the book. So what I have, let's draw the given on a number line. I have a car, initially was 0 second, was not moving. It moved for time, how much? 6 seconds. Okay. The acceleration was 3 meters per second squared. Good. It's telling me first, part A, write the equation of motion of motorcycle. Equation of motion always gonna be X. Take a look. I use this rule when starting from what? Starting from rest. I can use this rule. So X equal to half at squared. Remember, equation of motion, time, and X, say always unknown. So X equal to half, acceleration given a 3t squared. So X equal to 1.5 t squared. 1.5 t squared. That's my equation of motion. Part B. Part B is telling me express the velocity as function of time in terms of t. Let's get back to my URM. Which equation has velocity as equation? The second one. So V final equal to at plus V initial. So V final equal to, substitute the value of acceleration, gonna be 3t plus 0, because starting from rest. So V final equal what? 3t. Let's go to part C. Now we're going to use what I mean. He's telling me find the velocity at time equal to 4 seconds. At time equal to 4 seconds. So I'm gonna use this rule, this equation of motion, to get the velocity at time equal to 4. So V final equal to 3 into multiplied by 4 equal to 12 meters per second. That's why we have equation of motion. Okay. That's the velocity. And it's telling me us also find the position. Here velocity, here present position. So X equal to 1.5, substitute the time squared. Using calculator, gonna have 24 meters. Let's go now to part D. Party is telling me find distance covered between 4 seconds and 6 seconds. Over here I don't have number line, but I have one thing is better, equation of motion. Equation of motion can tell me what the position at what time he give me. So at t equal to, for example, 4 seconds, x position of it was, for example, 1.5 by 4 squared equal to 24 meter. At t equal to 6 seconds, x was 1.5 by 6 squared equal to 54 meter. So find the distance covered between 4 and 6 are good. Deduce the average velocity now. So what's average velocity? Average velocity. Change of velocity, change of this, change of displacement over change of time. Okay, change of velocity and v x final minus x initial, so 54 minus 24, and from 4 to 2, how much I moved? 2 seconds. So my final velocity or average velocity gonna be 15 meter per second. That's example 2.8. Now let's go to exercise 2.13. It's telling me that I have a equation of motion of a stone falling to the ground. Here I have a ground. It's represented by this equation, x equal to 5t squared. He gives you this is given. He's telling you what is the nature of motion. Okay, how should I do it? He didn't tell me that it's URM or UARM. But equation of motion, we know that for URM x equal to for example x equal vt, and here x equal to half a t squared. If I'm starting from rest, over here I fall, so v initial was 0. Okay, how should I know which one? Let's compare the t. Over here is t power 1, here is t power 2, but the equation is giving me also gonna be t power 2. By comparison, it's gonna be UARM because they have same time constant. They have same t squared. Now let's get the acceleration. Take a look. I have the equation given x equal to 5t squared, and the general equation is half at squared. By comparison, everything multiplied by t squared should equal everything multiplied by what also? T squared. So what do we have? A over 2 equal to 5. By cross multiply, acceleration gonna be 10 meter per second squared. Pay attention for this idea. Question B. What is telling me? What is the velocity, or what is the speed of the stone after falling 20 meter? So you told you that x was what? 20 meter. Velocity equal what? This. And of course you have acceleration equal to 10 meter per second squared. Let's get back to our equation of motion. Good. Let's get back to our what? Equation of motion. So I have position, I have v final. All of them, take a look. All of them have time, but I don't have time in it. So let's get back. So velocity equal to at plus 0. V initial is 0. So velocity equal to 10t. But take a look. The problem over here, I don't have time. But since he gave me distance, I can use another rule to get time from it. We know that x equal what? 5t squared. So instead of x over here, let's substitute value of 20. I get time from it. So 5t squared divided by 5 divided by 5. T squared equal to 4. يعني t equal to 2 by radical. Okay. After finding this t, substitute the value and this t over here. So what do we have? Velocity equal to 10t. So 10 multiplied by 2 equal to 20 meter per second. Pay attention, sometimes I have to use 2 or 3 rules to get the answer.